Hello everyone, it's Mr. N here, and in this video we've got our review for the first part of the Chapter 5 test. This is our second review. You've received multiple review sheets. This one though, we're going to go ahead and post up here as a video. So for this first problem, let's take a look at this. Find the derivative of each of the following. So basically I'm asked to find the derivative with respect to x of this problem. So this is FTC, and what we had said to do is we're just going to simply insert that in here with a chain rule. So taking the derivative of dx with respect to x, in this case would be 1. That's our chain rule. So over here, this just ends up being x cubed plus 1 times this 1, right? Because we still have that chain rule that's being applied. Okay, for the next one, taking the derivative here, the one thing you should notice is notice the bounds on this. Since we want the derivative, this needs to be up top. So we can switch this around to say from 5 to x, but we need to put a negative out in front. And as soon as we do that, now we can plug the x in and then take the derivative of that to dx. So we end up with a final answer of this negative that's out in front, and then the 3x sine x times the 1. So we'll just keep it at that. Okay, and finally for this last one here, again, we're going to apply the chain rule. Simply, we take the derivative here with respect to x, so we're going to apply the chain rule onto this, so this gives me the 2x, and then I simply take this x squared and substitute it in here. Again, this lower variable, sometimes we often refer to it as a dummy variable because it really is not going to impact our problem. So over here we end up with the cosine of x squared times this 2x since we applied the chain rule. So you can leave it like this, or you can write it as 2x cosine x squared. Either way is fine. Okay, moving on to number 2. For number 2, it says suppose big f of x is the integral from 1 to x of f of t dt, and f of t is the integral of 1 to t squared of 1 plus u cubed du. And we are finding this at f double prime of 4. So basically what we need to do in this problem is, this is our first derivative. We take that derivative, then we end up with our second derivative. So we will take this first derivative, substitute the x in, then take the second derivative and substitute that in. So basically, in this problem, what we end up with is when we substitute this in here, we cannot forget the chain rule. So this part of it will become 1 plus the t squared, but it's really the x, because over here, this is going to be the f of x when we take our derivative. So we end up with 1 plus the t squared cubed over here times this 2t. But again, it's really this x, because this one, the chain rule here is times 1 will end up happening. So this is really going to end up being as 1 plus x to the 6, because this is t to the 6. So we said it was going to be our x times this 2x. So that's what we end up here. And we are asked to find this at x equals 4. So this becomes 1 plus 4 to the 6th times 2 times 4. And working all of this out and solving it, you get 32,776. So now let's move on to number 3. And in number 3 here, we're asked to integrate each without a calculator. So some of these may take a little bit of work. On this first one, it's easier if you just go ahead and distribute this and write this as x squared minus 3x. So that's what we'll go ahead and do, and this is what we're going to integrate. So we'll take the antiderivative of this one. So this one ends up being 1/3 x cubed minus 3/2 x squared on the bounds from 0 to 2. Substituting these in yields 8/3 minus 12/2 as the first part, minus 0. When we put in 0, we're going to get 0 on both sides. And this ends up being negative 10/3 as our final solution. Okay, for the next problem over here, again, One thing we're going to talk about later is, since this is a polynomial, we could have even and odd integrals, and since these are symmetrical, there are things we can do. But we're not going to worry about that right now. We'll just go ahead and take the antiderivative here, so we'll go ahead and integrate this. So we're going to end up with 1/3 x cubed minus x squared plus 3x on the bounds from -1 to 1. And substituting those values in, I'll get 1/3 minus 1 plus 3. So I substituted the 1 in. And now minus, let's go ahead and substitute the -1 in, and I'll get -1/3 minus the 1 minus the 3. And cleaning all this up and solving it, you get 7/3 minus -13/3, which ends up being 20/3 as our solution to that one. Okay, moving on to number 5. Again, we're going to go ahead and integrate this, and we're going to end up with 3/2 x squared minus 1/16 x to the 4th. Again, this is 1/16. You could verify it. If I took the derivative here, I'll get 4/16 x cubed, and that'll reduce down to this 1/4 right there on the bounds from 0 to 4. So taking this on those bounds, I end up with 4 squared times 3/2, so that ends up being 48/2, minus, and then here I'm going to say 4 to the 4th over 16. 4 to the 4th is 256/16. When I put in the 0, I'll get zeros on both sides. So when I substitute that 0 in, that goes away. So this will end up being 24 minus 16, which gives me a final answer of 8. All right, number 6, very similar to number 4, but again, the bounds are a little bit different. So it ends up integrating. It's very similar. This is x squared, that's x cubed. So let's go ahead and integrate this. This is 1/4 x to the 4th minus x squared plus 3x on the bounds from -2 to 2. So over those bounds is what we're going to integrate it from. Plug in the 2. You get 16/4 minus 4 plus 6 minus the 16/4 again, minus 4 minus 6, so this ends up being 6 minus the -6, which comes out to be 12. Okay, next problem. Over here we're going to integrate this, so we end up with 1/3 x cubed. Now this we're going to change to be x to the 1/2. So we go up a step, so that's going to be plus 1, so 3/2. And then what do we put up here to make this a 1? We have to multiply it by 2/3. And this is on the bounds from 0 to 1. Working all of this out, when you plug in 1, you're going to get 1/3 plus 2/3 minus the 0 when you plug 0 in. So this ends up being 3/3, which is 1. Okay, and finally for this last one, what we're going to do is we're going to take a look at this, but be careful. Let's notice something. I haven't covered this so much here on all these bounds, but make sure these bounds always have to work as our domain in our equation before we even integrate. And all of these have worked so far, but take a look here. Will this work? Well, let's see. If I change this, this is 1 over x to the 6/5. If I put 0 in here, what happens? I get 1 over 0, undefined, can't do it. So I can't integrate it since it doesn't work at 0. It's not continuous at 0. So this is not continuous at 0, so the whole thing does not work, so no solution. Okay, so always double check your bounds to make sure they work before you start to integrate. That way you don't waste time, because by hand you often will get an answer. If you're using a graphing calculator, it'll give you no solution, it'll give you an error, but by hand sometimes you will get an answer, and that answer is wrong because it's really no solution. Okay, sliding this up, looking at number 9. We're going to go ahead and do number 9 later. I don't have enough room on here. That's the reason. I put it on the second page. So let's go ahead and skip that, and we'll move on to number 10, and then we'll come back to number 9. So for number 10, On the first question here, we are asked to integrate from 1 to 5 of x squared plus 3x dx using left, right, midpoints, trapezoids. One thing I failed to indicate here, let's go ahead and put it in. We want n to equal 4. So we want 4 rectangles, 4 trapezoids in this case. So for the first one, we know that the area is the sum of the delta x times the height. So the sum of the rectangles, the Riemann sum. And in this case, we are using 4 rectangles. If we sketch this out real fast, here's 1, 2, 3, 4, and 5. Now, let's find our delta x. Delta x, we said, is b minus a over n, because I'm choosing to make these evenly spaced. If it's not evenly spaced, each delta x will be different. But in this case, I'm choosing to make them evenly spaced. We've got delta x being b minus a over n, so 5 minus 1 over 4. This becomes 4 over 4, which is 1. So, in this case, this spacing is 1 between every single value here. Now, if I put in f of 1, I'll get 1 squared plus 3 times 1, so I'll get 4. So I'll get to a height of 4. Now, since I want to use left endpoints, that's where I start, and that's how I make my first rectangle. F of 2 would yield my second rectangle. That's my left endpoint. F of 3 would be my left endpoint. And then f of 4 would be my left endpoint. Notice I'm not using f of 5. That would end up being a right endpoint. I end up with only left endpoints there. This is my first rectangle, second rectangle, third rectangle, and fourth rectangle. So in this case, using my delta x times h, my delta x is 1. Now, all your heights right here are your f of the equation values. So in this case, it's f of 1 plus f of 2 plus f of 3 plus f of 4. Notice I did not go to 5 because 5 would be another rectangle. It would have that endpoint, but we want left endpoints. So we have 1, 2, 3, and the heights of 4. So plugging in these values, I end up with f of 1 being 4, f of 2 being 10, f of 3 being 18, and f of 4 being 28. Adding all these up and taking the final sum, I get 60 square units for this particular problem. Okay, moving on to right endpoints. Right endpoints are going to be similar. So I know my delta x hasn't changed. My delta x is still 1 as I solve for it. So the spacing is 1. So 1, 2, 3, 4, and 5. What has changed, though, is I'm using right endpoints. So instead of starting off here at 4, I'll start off here what f of 2 was, which I believe was 10. That's my right endpoint. So I'll be using this to make my first rectangle, then 3 to make my second rectangle, then 4 to make my next rectangle, and 5 to make my last rectangle. Notice these are all on the right side, hence right endpoints. So delta x, so we want the sum of delta x times my heights. So in this case it's 1, and I'll use f of 2 plus f of 3 plus f of 4 plus the f of 5 this time. So we already found some of these. F of 2 is 10. F of 3 we found to be 18. F of 4 we already found to be 28. And f of 5, when we plug in 5 into our equation, we end up with 40. Taking the sum of these values, adding them up, I get 96 square units. Now, let's move on to the midpoint one. For the midpoints, again, it's the same process. I go through and I'm going to be, delta x will be 1, okay, so 1, 2, 3, 4, and 5. So I'm starting here and I'm spacing by 1, but look, this time I want halfway. I want the midpoint between 1 and 2. I want the midpoint between 2 and 3 for the height of my rectangles, the midpoint between 3 and 4, and the midpoint between 4 and 5. So that means the sum will be delta x times the height, the width times the heights. So in this case it's 1 times, now this will be f of 1.5 plus f of 2.5 plus f of 3.5 plus your f of 4.5. Those are the midpoints in between each one. So when I plug in 1.5 into my equation, I get 6.75. When I plug in 2.5 into my equation, I get, so this will be plus 13.75. 3.5 comes out to be plus 22.75, and then the last one comes out to be 33.75. Okay, taking the sum, I end up with 77 square units. So 77 times this one, 77. Hopefully you guys double check me on that. I did that rather quick. Okay, finally, using the trapezoid rule. Again, same concept. I have 1, 2, 3, delta x is 1, so that's why I'm spacing them like this. But this time I'm going from here to here. I'm creating that trapezoid. That trapezoid. So notice each of these have trapezoidal tops here. Okay? Now this delta x is really going to be our height, because we know the area of a trapezoid is 1/2 times the height times the sum of the bases. And these f of values will be our bases. So in this case, my delta x is still 1, which are the heights, and I'm using, take a look here. Let me outline this for you a little bit better. I'm using this piece, this 1 and the 5, only once, yet I'm using all these other pieces, the 2, the 3, the 4, twice. I'm using it in trapezoid 1 and 2, so piece number 2 gets used in both, piece number 3 gets used in both, and piece number 4 gets used in trapezoid 3 and 4, whereas the ends only get used once. So in this case, I'll end up with my sum delta x times the h times the 1/2. That's my trapezoid right here, and this ends up being 1/2 times my delta x, which is 1. Now this will be f of 1 plus 2 times f of 2 plus 2 times f of 3 plus 2 times f of 4 plus your f of 5. So we end up with 1/2 times the 1. Now when we plug in f of 1, we are going to get 4 times 2, f of 2 is 10, plus 2 times f of 3 we said is 18, plus 2 times f of 4, we said f of 4 is 28, plus the f of 5 here at the end, which is 40. So working this out, we end up with 1/2 times 156, which comes out to be 78 square units. And that is the answer for the trapezoid rule. Now, one thing to notice, take a look. Is this pretty close to the midpoint? Yeah. How far off are the left and the right endpoints? Left gave us an underestimate because it was increasing, so we had an underestimate here. And the right gave us an overestimate because the curve was increasing. So since the curve was increasing, I was above it, so that I got a bigger value. Here I got a lower value. What happens if I add these two up? What do you think I'm going to get if I take the average of the left and the right? Will I get the midpoint or will I get the trapezoid rule? Think about that. All right, so let's go ahead and move on to the last part of our problem here. So for part E, I want to find the exact value. Now finding the exact value of this just means I want to integrate. And that is our integration that we learned. You could take the limits as the triangles or as the rectangles become infinitely small using Riemann sums, but we said we're not going to go ahead and cover it. We talked about that, we covered it, but we said that's not going to be on the AP test, so now we're just going to focus on integration. So in this case, we want to integrate this and get the exact value by integration, so we take the antiderivative, so we end up 1/3 x cubed plus 3/2 x squared when I'm taking this, the antiderivative, on these bounds from 1 to 5. So I plug in 5, I get 1/3 times 125 plus 3/2 times 25 minus, when I plug in 1, I'm going to get 1/3 plus 3/2. So this ends up being 475 over 6 minus 11 over 6, which yields 232 after I simplify it over 3 square units, and that's about 77 1/3 square units. So taking a look at this, compare these values. Midpoint and trapezoid is pretty close. Left and right are not. They're a good value off on this problem. Okay, so now let's go back to number 9. And in number 9 it says, the accumulation of rainfall was monitored over a 10-hour period. The table shown records the data collected for the 10-hour period. Over here, we need to find, I did not indicate what you had to do in this problem. So let me indicate for you what you have to do. Sorry about that, guys. So for this one, I want you to estimate the total rainfall over the 10-hour period, and you will use, for part A, left endpoints, and for part B, right endpoints. Now, since we're going to estimate this, I didn't give you an n here, and often on the AP test they won't give you an n. So sometimes if they don't, you're just going to do it for 10 rectangles. Since we're going from 0 to 10, just go ahead and do it for all 10 rectangles, because each of these will have a different delta x. Notice I'm going here from 0 to 1, that delta x is 1. From 1 to 2.5, that delta x is 1.5. From 2.5 to 3.5, delta x is 1 again. So it changes between the values there. So the spacing changes, so you don't have a set delta x. So we can't use the formula b minus a over n because they're not equally spaced. So for this first one, for part A, we want to estimate this total rainfall over the 10-hour period using left rectangles. If you were to kind of quickly sketch a graph of this, now there's a lot of data points here to sketch. So on the AP test, they probably won't give you this many. But if you took a quick sketch, you'll have 0, 0. You've got 1, 12 right here. And then you've got 2.5 to 22. So you can kind of get an idea starting off that with left endpoints, we want to start here. So our first rectangle will have a height of 0 and a delta x of 1. Our second rectangle will have, this is at 2.5, will have a delta x of 2.5. And left endpoints will have a height of 12. Our third rectangle, this is at 3.5, will have a delta x of 1 and then a height of up here at 22. So that will be our third rectangle. So this was our first, this was our second, that's our third, and so on. So now, having said that, we know that the sum of the delta x times the h for each rectangle, the width times the height, will give me my total accumulated rainfall over that 10-hour period. Now, for the first one, we have a width of 1 and a height of 0. So from 0 to 1, I have a height of, let me write this as the delta x times the h. So in this case, I'll have the delta x as being 1 times a height of 0. So we want to start at 0 for left endpoints in this problem. So this is where we're starting. If we did right endpoints, we would start at the 1. So the next one will have a delta x from 1 to 1.5. This delta x is, to 2.5 will be 1.5, and the height, I'll take it here at this value, which will be 12. The next one goes from 2.5 to 3.5. So this delta x is 1, and the height, again, I'm taking it at the 2.5 value, which will be 22. The next one ends up being from 3.5 to 4, so 0.5 times a height of 10. And then I'll end up with 1.8 times a height of 5 plus 0.4 times 13 plus 1.3 times the 11. So again, we went from here to here, and then the height was this one, since we're choosing left endpoints. Okay, then we've got 0.5 times 6, then 1.5 times 2, again 1.5, left endpoint times this height of 2, and then I can't squeeze it in there, so I will put it right down here. This will be plus 0.5 times 6. So 1.5 times 2 plus 0.5 times 6. Now let's go ahead and simplify all this. I get 0 plus 18 plus 22 plus 5 plus 9 plus, this will be 5.2 plus 14.3 plus 3 plus 3 plus 3, which gives me a total of 82.5 inches. Okay, let's move on to part B, and in part B, we're going to use right endpoints. So we're going to start at the x equals 1 or value. So for right endpoints in this case, let me erase a couple things that we have here if it'll let me. Probably won't let me, but yeah. We'll just do it in the other color. So we're going to start at the right endpoint. It's going to be that's my delta x, and that would be my height. So the 1 will correspond to 12. Then the right endpoint, from here this way, that's my height. Right endpoint, that's my height. So the 3.5 would, so this change would be delta x would be 1, and that would be a height of 10. So let's go ahead and write all that down. So I start at 1. So this will equal, my delta x here is 1. So let's indicate that. That's 1, and my height would be 12. So this first value is 1 times 12. Plus the second value, my delta x goes right here from 1 to 2.5, so that's 1.5. And the right endpoint is this side. So 1.5 right endpoint would be the 22. So 1.5 times the 22 plus, this is 1. Again, I'm going from here, 2.5 to 3.5, and a height, right endpoint, so that would be 10. And then 0.5 times 5. And then the next one will be 1.8 times 3. Again, 1.8, right endpoint. I'm going to use that value that corresponds to it, 13. Oops, that should be 13. 1.8 times 13 plus 0.4 times 11 plus the 1.3 times 6 plus 0.5 times 2 plus 1.5 times 6. Again, I'm going 1.5, but right endpoint would correspond to a height of 6, and then plus the 0.5 times 0. Cleaning all of this up, I end up with 12 plus 33 plus 10 plus 2.5 plus 23.4 plus, you guys need to double check me on this one because I am doing this rather quick, plus 7.8 plus 1 plus 9 plus 0. 9 plus 0. And adding all this up, I get 103.1 inches. Okay. Taking a look at part C. Now in part C it says, using the left endpoint approximation, so this value right here, so this was 82.5 inches, estimate the average rainfall over the 10-hour period. Well, we've got 82.5 inches in 10 hours. Just divide it out. And then in this we'll end up with 8.25 inches per hour as our average rainfall. So hopefully that helped. Again, let me know if you have any questions in class, and good luck studying for your test. Make sure you do the other review sheets I've given you as well.